Hey guys, today we're going to be going over the 2011 Calculus BC FRQ number 3. So this is a non-calculator 9-point question and it is 3 parts. So the givens say that we are given f of x is equal to e to the 2x, and we have the region R that is bounded by the first quadrant and the coordinate axes, the graph of f, and the vertical line x equals k, where k is positive. So part A is asking us to find an equation or an expression involving an integral that gives the perimeter of R in terms of k. So to make this more visual, I'm going to number each of the sides of this region R. 1, 2, 3, and 4. So parts 1, 2, and 3 are fairly simple. So perimeter is going to be equal to 1 plus 2 plus 3 and plus 4. Which will be equal to, this is 1. This right here is from 0 to k, so k. Here is e to the 2k. And then side number 4 is going to be our arc length. So we have to remember that our arc length formula is equal to the integral of the square root of 1 plus f prime of x squared dx. So we have our integral from 0 to k of the square root of 1 plus f prime of x squared. So we have our f of x right here, and then we just derive it. So we start with our original, and then we take the derivative of the exponent, which is 2, and we just multiply it. So here we're going to have 2 e to the 2x squared dx. And that is your answer. You could also simplify this out in the middle to be 4 e to the 4x, but that's not necessary. Now part B is asking us to rotate the region R about the x-axis to form a solid and find the volume. So we need to remember our formula for volume. It's going to be pi times the integral of our area here, or our curve squared. So we have pi times the integral from 0 to k of e to 2x squared dx. And then from here we just simplify everything out. And that is our volume. Here we need to remember to include the pi because that's something that's very easily forgotten. I know I forgot that a couple times on a couple tests. Also be very careful when you're integrating because e to anything is just a very special kind of integration. So you're going to take the derivative of your exponent and you're going to divide by that. So, and you can check your work when you do this by just deriving this right here. So we'll have e to the 4x times 4, and then the 4 and the 1/4 will cancel out to give you back to your e to the 4x. So we know that this is now correct. Also remember when you go to plug in your k and your 0 into this right here, that e to the 0 is 1, not 0. In part C, we're going to take the volume that we found in part B, and we are going to find dv dt given that our dk dt is 1/3 and our k value is 1/2. We are going to start by first listing out our givens. So we are given dk dt and our k, and we're looking for dv dt. So we start with just our volume formula from part B. And then because we're looking for dv dt, we are going to derive this formula. And now that we have this, we are just going to plug in everything that we know. And then from here, we just simplify everything out so the 4's cancel. And then we get and that is our answer. Now some things to keep in mind when you're completing an FRQ on an AP test are things like how to just get points if you don't know what you're doing. So looking through the scoring for a question like this, you get in part A a point for an f prime of x, an integral, and your answer. So something that's easy to do, if you can remember that your arc length formula involves some kind of f prime of x, just putting down an f prime of x, as seen right there, will get you 1 point. Also, perimeter is a fairly simple concept, so if you're able to get parts 1, 2, and 3, and you can't get 4, just put some kind of integral, and you might get points for that, because it says you get 1 point for an integral. So that's a pretty vague thing. Maybe you just get a point for writing an integral. For part B, you get a point for an integrand, limits, an antiderivative, and your answer. So again, if you can remember that a volume of a rotated region will involve some kind of integral. If you can just get the limits correct, that's a fairly simple thing that you can do because it's right there. Taking the correct antiderivative, if you get this part wrong right here, if you antiderive it correctly, you will get a point for that as well. For part C, you will get a point for applying the chain rule and an answer. So here will be your chain rule, and that's just something that you've known since pre-calculus, so hopefully you can remember how to do that. And then for an answer. And if you can't get part B for some reason and you see that part B and C are connected, just write down some kind of volume formula in part B, and you won't get points for that, but then if you apply that correctly in part C by just incorporating volume and K in some way, then you will be able to get points down for that. Another quick tip is just for part C. I know that problems involving the instantaneous rate of change for like volume and stuff like that is very intimidating to look at, but for me, I don't get intimidated by them because I just think of it as you're taking a basic formula, like just your volume right here, and you're finding a way to incorporate your unknown and your knowns, and you're just solving for what you're looking for. You just plug in values. So what we did is pretty much just we have our volume formula from part B, and then we're thinking like, hey, we need dv dt in there. So how do you get that? You derive it, and then you magically will get your k's in there, and you will get your k prime in there because of your chain rule. And it's easy to forget your k prime right here because you think that it's like an x, and you're like, oh no, like just dx, and it's 1. But if you look carefully here, it's in terms of t, so you know it's a k prime, and that's how you'll incorporate your 1/3.